Go ahead and take a look at the fundamental identities. We're going to start with the reciprocal identities. So we're taking a look at our cosecant function, our secant function, and our cotangent function. And each of these can be written as a quotient. So if we take a look at cosecant, we can rewrite that as 1 over sine of theta. Secant is written as 1 over cosine of theta. And cotangent can be written as 1 over tangent theta. We also have some quotient identities, which are going to involve tangent of theta and cotangent of theta. Again, each of those can be rewritten as a quotient. So if we're taking a look at tangent of theta, we can rewrite that as sine of theta on top and cosine of theta on the bottom part of our fraction. Cotangent theta is the same thing as cosine of theta on top and sine of theta on the bottom. And then you have three identities that are known as the Pythagorean identities. The one that we'll probably end up using the most is the first one you see listed there. We have sine squared of theta plus cosine squared of theta equals 1. And then you have two additional ones. The one in the middle is tangent squared theta plus 1 equals secant squared theta. And our last one, cotangent squared theta plus 1 equals cosecant squared theta. Now, I have a lot of students that'll ask, do I need to memorize each of these fundamental identities? The answer there is both yes and no. You don't necessarily need to memorize them, but you do need to understand what they are and how to use them. The more you use them, the easier it's going to be to remember them. We're going to take a look at one of the Pythagorean identities. I'm going to go ahead and start with sine squared theta plus cosine squared theta equals 1. And I'm going to show you how to work with other identities that are on this list so that you can actually produce one of the other two Pythagorean identities. So let's go ahead and take a look at this one. And now you can pick how you want to go about working with this problem. I'm going to do a little bit of rewriting here to get us started. Keep in mind what it means to square something. You're going to notice that when you're working with these identities, the 2 as the exponent is going to sit between the sine function and the theta itself. So this is really the same thing as saying sine of theta, that whole thing squared, plus cosine of theta, that whole piece squared equals 1. And now I'm going to go ahead and divide each of these pieces by cosine squared theta. And let's go ahead and take a look at what happens. This middle piece is probably the easiest one to work with. Right? You have a cosine of theta, that whole thing squared up on top, and you have cosine squared theta on the bottom. Obviously, when you divide those out, that's going to divide out to give us a 1. And I'm going to go ahead and do a little bit of rewriting here with this first term. Keep in mind, when you are taking sine of theta, that whole thing, and squaring it, that really means you are multiplying sine of theta by itself. Right? That's what it means to square something. And the same type of thing is happening when you're working with your denominator. On the bottom, you're multiplying cosine of theta times cosine of theta. That's what it means to square something. And let's go ahead and take each of these and kind of break apart the fraction. If I just look at this piece, sine of theta on top and cosine of theta on the bottom, if I go back and take a look at my fundamental identities, that's the same thing as tangent of theta. So I'm going to replace this one with tangent of theta. And the same thing is going to be happening here. Keep in mind, right, these are pieces that are being multiplied together. So sine of theta on top, cosine of theta on the bottom is going to give me tangent of theta. And obviously when I'm multiplying those two pieces together, it's the same thing as tangent squared theta. I'm going to go ahead and bring this one down that we had. And now let's go ahead and take a look at what happens on this right side of our equal sign. I have a 1 on top and a cosine squared theta on the bottom. So I'm going to go ahead and break this apart as 1 over cosine of theta times 1 over cosine of theta. Now I'm not changing the problem at all. Notice on top here, if I multiply 1 times 1, I'm going to get right back to that numerator of 1 that I started with, and cosine of theta times cosine of theta is the same thing as cosine squared theta. Now I'm going to go back and take a look at my fundamental identities. If I'm looking at 1 over cosine of theta, right? That's the same thing as secant of theta. So I can replace this with secant of theta. And I can do the same thing with this fraction. Replace it with secant of theta. And obviously if I multiply those two pieces together, I'm going to end up with secant squared theta. Now I didn't have to do any memorizing to get this Pythagorean triple, but you're going to notice that this was the equation that was on the bottom middle part of our earlier screen. Right, I have tangent squared theta plus 1 equals secant squared theta, which is the same thing that we had right here. Now we can do the same type of thing to get the other Pythagorean identity. We could go back to that sine squared plus cosine squared equals 1 formula, and we could take each of those pieces, and this time we could go ahead and divide everything by sine squared theta, and that would actually give us this equation that we have down here. Now I'm not going to go ahead and do that one. You can do it as practice, and then just go ahead and check your answer. So let's go ahead and take a look at one more example. I'm going to go ahead and use one of my reciprocal identities. I'm going to actually go ahead and use that first one that's listed. Cosecant of theta equals 1 over sine of theta. Now remember that when you're working with identities, you're allowed to manipulate these just like you would any other equation. So let's go ahead and start with this one, and let's pretend we want to go ahead and solve this one for sine of theta. So we want our equation to read sine of theta equals everything else. Now, in order for me to get rid of my denominator here, remember I can multiply both sides of an equal sign by something. So I'm going to multiply both sides by sine of theta. And on this right-hand side, the sine of theta are going to cancel. It's going to leave me with a 1. And on my left-hand side, I'm going to copy it exactly as I see it. I have sine of theta times cosecant of theta. And since these two pieces are being multiplied together, I'm going to go ahead and divide both sides by cosecant theta. So these are going to cancel. And I'm going to be left with sine of theta equals 1 over cosecant theta. Now, what you've really done is created a brand new identity. You can add this to your list if you want, but just know that you don't have to. Obviously, if you know a couple of those key identities, you can manipulate them along the way to get them to read what you need them to be so that you can use them in a problem.